does like multiple mathematical calculation, and it does like all type of algorithms, and it does like many things using the supercomputers, and we have like a lot of chipsets and hardware development is there. So that's why we as a human, as a whole community, we could accomplish this technology in right now in this era. So that's what it is. And we can simply take, we can tell like holistically what's artificial intelligence. Artificial intelligence system which it's actually will replicate human intelligence. That's what the AI it is. And machine learning is also like subset of the artificial intelligence, and generative AI is a subset of machine learning. So that's how it has been. So we can holistically call it as a part of AI. Not a generative AI is not AI actually. So that's what I want to make it clear. So that's the one thing. So this is how the system here is. And why we call it as an intelligent system? Because a system which able to interpret and act and able to decide and able to learn from their mistake, it's called as intelligent, right? As a human, we are intelligent. We possess this cognitive ability, so to able to sense and understand when what is happening. So that's what we could able to replicate with the idea of generative AI and all the LLMs we have right now, and the large language models replicate whatever the human intelligence it has, but it works differently what we have learned. So I will go through the session so you will understand what it is, but just understand what's the difference between an intelligence system and a rule-based system. An intelligence system which understands and able to sense and decide, and it able to act on the ideas, so that was intelligent is. Okay, so what's everyday AI versus generative AI? It's the difference is like pretty much simple, like able to do analytical things that able to predict or something like we have to do a classification problem, or we have to do any forecasting, like probably with the earlier data, with the historical data, we could able to predict some probabilities that what should be the climate for tomorrow. So that's the machine learning does it. Okay, so able to get my point, right? So with the historical data, we could able to predict some of the outcomes with the earlier data. So that is what it is, and that's machine learning. But generative AI is something we could we could able to generate from scratch, and it just learns from the earlier data, but it able to generate it. So that's what the difference is. It just gives a predictions. The analytical the machine learning gives the predictive and analytic AI, but generative AI is that gives the content out of scratch with the earlier data which has been learned. So this is what the difference between both everyday and generative AI is. And generative AI is a multimodal. What I mean by multimodal is it able to handle different types of data. So text, image, audio, and code, video, data. So everything can able to be managed by generative AI. And how it normally does is through help of NLP, natural language processing. So through the NLP only, we able to came with the text generation. That is whatever we are using right now, right? ChatGPT, Claude models, everything. So that's how it has been started. So text based was a starting point, and how image has been came up is through the concurrent neural network, where we could split the images as a base 64 form, or else we could say like bits, right? Each individual images will have its own pixels. So that pixels, through that pixels we able to form a certain computer vision, so that the model able to understand what's behind the pixel. So that is what it able to understand the image data. And audio something like a whisper tool. Whatever for say I'm just speaking, right? These words can be converted as a text. So this conversion, once it's converted as a text, it becomes the text data. So videos, this three is completed. So videos normally how we resemble, right? So all the videos is clubbed with multiple screenshots, or what we could say. The videos can be collidely, we can combine on multiple screenshots and compile one videos. So that's how once we have the screenshot, it becomes images. And how we handle the images, through the base64 format or a pixel format, so that once the pixel format comes into picture and it, with computer vision we able to handle it. Same goes for the code and the data. So everything again is it falls to the text data. So this generative AI in the current era, it's a multimodal. So whatever, even if you send one video, it able to deduce what content backed with the video. So that how it is in the current era. So like almost it covers all set of data. And this is something like basic how the model learns. Like if we give to feed the data to certain algorithm, it able to predict a pattern within the data, and out of that pattern it just deduce the parameters and with the output. Though uh, I told it in a very short form, it has a very bigger picture behind it. So I will explain it further in later of the session. So this is just like I want to touch base in very minimally. So this is something, and I just want to explain why the current technology has come into this picture, and that's duly complete reason is due to the transformers. So transformers in the electrical form, it's different, but in the sense of A and the DS, it's actually whatever we are currently using, right? The Chat GPT, Claude model, and whatever the Ben model and Grok, everything is the transformer. It's a transformer algorithm, a transformer neural network algorithm. So yeah, before the existence of the machine learning and all those stuff, we were actually going through a software era of the rule based system. What the rule based system is like. Um, when you guys should have been remembered. So if we would have like logged out with the yahoo.com. If we log in the Yahoo, it did not have any intelligence system. Like we have to give whatever the instruction, it is backed with the rule based hard coding. So this scenario needs this answer, this scenario needs this answer. There is a null intelligence involved in that. So that was the rule base. I'm just telling the era period like prior to 2017. This was the system and the architecture, and the software also was existent with the rule base only. And all over the world, that was the case. And then the machine learning was prevalent with some of the traditional models like XGBoost, CAD Boost. So all these models was being existent, but it does a classification or a predictive problem, not as a text summarization. So to handle the text, we didn't have a fine-tuned or whatever the current advanced technological model like we have now. We didn't have in that era. So RNN was prevalent for before 20 years itself was prevalent, but RNN has its own limitations because, for example, I will tell what's the limitation. For example, this is example: the faculty designed a new course. So, okay, this is one sentence. And what the limitation with the RNN is that once this sentence is getting generated, right? The faculty is one token and designed is one token and a new course, and this is a separate tokens. So the RNNs couldn't retain a memory for the sentence. For example, if it wants to go through the new course as a next word, it will probably forget the first two letters, the faculty. So it has its own limitations. We have to do a memory optimization, and it has its own, we have to do that probably. So we can't do it for like entire paragraph or for an entire document. It's not possible. So to cut short this, the LSTM came into picture. So LSTM is nothing but long short term memory model. So what it does is it had limitations covered by whatever the limitations are RNN. It covered through the LSTM, but it has also like one limitation. Um, it had though it had like two gates, note this point: it had gates, input gates, forget gates. What and all the important things it have to remember, it will just put in the input gates, but whatever it have to forget to go to the next sentence or the paragraph, it will just put in the forget gate. So it couldn't retain very large sentences or whatever. For example, if you guys like use chat gpt, you will just ask a simple question like what is the capital of France. It probably explained the capital of France along with additional some points, whatever the special thing, like in Paris we have this Eiffel Tower. All those contents will be automatically generated out of the context. Whatever the context we give, it just gives. So that kind of capability we didn't have in the LSTM model. So LSTM has a limitation because it is also like sequential. For example, once the faculty completed, then only it goes for the word designed, not before that. But these all things got reformed once the transformer got in the picture. So there was a paper called "Attention is All You Need." It was given by Google Brain developers, and it was like pivotally headed by um, actually. So he's the one who was heading that paper, and he is the one who released the transformer. But they what they did is actually they converted the French language into the English language using the transformer. But through that, GPT came into the picture, and GPT used only the decoder model, and with that, it just came into the as a product. And today's existence, right? GPT, Claude, everything got transformed. But starting point is 2017. It was released by Google's Ashish, who's also like is now one of a brainchild of Transformer. Whatever the AI technology we have, he's one of the guys who was actually brainchild for everything. So that is one, and that's where the Transformer started. And I'll just tell what Transformer actually does is, okay. Yeah, Ashish Vaswani is his name actually. Okay, so Transformer, it does not do in a sequential manner. For example, the faculty designed, it will not do in a word by word manner. It will do the process parallelly, and it automatically, if the process is parallel, it is faster. And we as a human or people, we love things which is faster and which is efficient, right? So that's why Transformer was a turning point, and it did a lot of reform. As you can see, we are going through a different line of industry as a whole, from IT sector to everything has been impacted. So this is the starting point where the natural language processing got evolved due to the transformer. So this is what the starting point. And yeah, and the foundational model. So foundational models were nothing but the models which is trained with the generalized data by a company. For example, a GPT-5 is there, right? 5, 5, 4, and Claude, what's this, a Sonnet, um, a Sonnet, Haiku, multiple models is there. So these are the foundational model. Foundational models, nothing but it is trained with the generalized data, and it is also trained with the, like, huge models, huge data. So it is a bigger model, and they host and they give us the API. So we could able to, as a customer and the people who are using it, we can consume it. So that's what the foundational model is. So that model will able to do multiple tasks, rather than fixated on a single task, which is not only for like a generalized, not only for the specific domain purposes. For example, a model which works only for the aerodynamics subject. So it's not a generalized model, right? If we ask that particular model any question like capital of India, it will just throw a rubbish term. But it won't happen in the case of foundation model because it trained with the large data. So that's one thing. And yeah, the progress, why it came, is also like the technology advancement. So Nvidia was able to develop like multi-core GPUs, and GPU is a pivotal. I will just tell and further late. But just remember that for training a transformer, GPU is the most pivotal thing to have, because in CPU it's not possible, because a general core in the CPU, it's not capable to hold this much of amount of computational which goes through the transformer or in the GPUs. So just remember that GPUs is a pivotal thing to have in the transformers. So what's the attention? We have this attention mechanism in the transformer. What's the attention? It's just nothing but right? Generally, if you ask people like GPT, they will tell like A is that, this, that, and Chat GPT does many things. But that's not the case. It just remembers all the data pattern, and it just predicts the next word. That's it. through your context. For example, I'm just asking one question. Okay, well, this presentation itself, like I'll just put crop it and I'll just put, okay, out of this presentation, what is the context you can generate out of it? What it does is like it will convert this image into a context. What's the context? Okay, transformer turning point and attention in 2017. What it does is it just maps the vector mappings. Um, Whatever the training data it got mapped, it just predicts the next word out of it through the linear probabilities. That's the transformer. That's a max transformer can do. It will not do something like extra things or very magical things. Though that's not gonna happen. It just predicts the next word to it. That's it. But it will do in a very efficient way and in a smarter way, because it will able to interpret and it will able to understand the data patterns behind the transformer. So that's the thing behind the transformer. That's one. And yeah, I was telling, right, for example, just see this sentence: a teacher explained the model because it was unfamiliar. What we'll do is, if, for example, as we as a human, we prone to do a lot of grammatical mistake, right? Because we just see, okay, instead of this place, this word may come or this word may come. Okay, which should be the one? But as a human, we can't do a million types of probabilities in our brain because we have this limitation. But that's not the case for the transformer. It can do a million times of computational, because like this, it will take like similar sentence like this, and you just see all the probabilities. And if like this sentence, it will take and it see all the probabilities. And what I will do is like a majority of words backed with, like, if this way the sentence is coming up, what we'll do is, okay, it is coming uh, behind the because lot of the words. So that's how it just understand the patterns. It won't understand the sentence at all. It do not have that capability. It will learn only if it is like repeated for more number of times. But it's not the case for generalized words. It won't remember anything. It just understands the data patterns. So that's the one thing we have to remember. And yeah, like I was telling, right? Token embedding, self application, feed forward, normalize, and residual. Just remember this. Okay, no word is no word can be directly feed to the transformers. Okay, that's not how it will be get trained. It will be trained with a textual form, but as a token. Once the token has been converted to the embeddings is nothing but conversion of a word into a numbers. Only through the numbers in the vector space, it will just put all these words in the vector space, and then it learns the data patterns. That's how it will do, not as a word completely. For example, what you may ask, like, what is a token? Okay, let's just take this example. Generative AI is suppose interdisciplinary learning, but as the transformer, how it takes as a token is, for example, generative is one token, but this is one example. It depends on the tokenizer of a transformer. It completely depends on the, because tokenizer is something, a component within the transformer. It changes from people to people, product to product. For example, a tokenizer may in ChatGPT not be similar to the Claude. So this is a difference. But let's keep it this way. The tokens is nothing but it just like splits of the words, so that it may have the numerical conversion, so that the transformer will be able to understand it. So everything is backed with the IDs will be backed with the tokens, and tokens will be backed with the embeddings. This is the interrelationship between this. Okay, so all this will be interrelated, and it will be like connected. Once it is converted as an embedding, then these embeddings will be put in the vector space. Of the vector space is nothing but vector stores of a transformer. What this vector stores will have is, it will just you just can keep as a one example. These are the words, right? These words will be put in the vector space, and this vector space will have its own relationship pattern. Okay, this pattern will be maintained, and this pattern will be like intricately read through all through the vector space, so that the model will understand. Okay, generative AI is a term. But if you see in the vector space, this 4210 4347 will be interlinked and will be stored in the vector stores for multiple times. Okay, the lot of times it has been combined, it is going to be combined. So it is a combined token. It is a combined word. It will just understand that this is what I'm just telling. It will just predict the next word through the probabilities, not with any magical things or nothing. Only the probabilities. It will probabilities through the non-linear equations. It will just work. I just don't want to put all these equations and mathematical problem, because it will just go to the very core of the transformer. But I don't want to do that. But I'll just explain this way. Okay, because just remember, it is a token, and that token will be converted as embeddings and put into the vector space. And the vector space, these tokens will be interrelatedly and put in the probabilities, and this model will automatically select the which probabilities is better. Okay, just remember in this way. Okay. Okay, you just remembered, right? How these models are working. Way of working, it has been known. But how the large models are being trained? That's one of the mythical questions people normally don't really see what is going behind. For example, whatever the model we have, right? Everything is trained with a certain data. So the data may be the format of the data may be different. For example, HTML is a formatted data for a web applications. Okay, a markdown is one of the innately format for the transformer, because normally if a human I think people may have used Claude skills, Claude skills of it you would have seen. But if you add one skill to the transformer, it may have added with .md file. That should be the command. It automatically runs, but it runs with automatically. You don't want to do anything. But I will ask people to try it out. If you guys are using Claude, just try to update one of the skills for your model or your application with the UI. In UI based itself, you can just update, and you can see it will be trained with .md file. So that's a markdown file. Markdown file is a innate format for the transformer. It will be trained with a certain data. Okay, so how it normally works is, for example, if I want to train one model, that model should know all the capabilities, all the policies, all the details, and all the alumni details, everything about the AMS college. Okay, so I have this all the formatted data and everything is ready. What I probably have to do is I have to collectively set a format, like a certain markdown files. And if I have a PDF file, I have to put a PDF files. And if I have a web application or a website for AMS college, so what I will do is I'll just collectively put all this into a segment of storage, and then what I will do is probably will clean the data and pass the data. Pass the data is nothing but PARSE, pass the data. So pass the data means we have to clean it in the certain format, so that the model able to understand it. Okay, and normalize it. Nothing normalizes is nothing. It's just conversion of the words into again numerical form, and we have to tokenize it. And once the tokenize it, we have to package, and we have to do a certain sequences training. Okay, this is how the normal model training. Even for the LLM, it happens in the same way. It may differ for the machine learning. Machine learning have the feature importance. All these things, feature training, everything is there. But for LLM, this is how it gets trained. If the model, the product, the GPT we are using, right? This is how it got trained. Okay, like I was telling, right? It will just predict the next token. That's the thing. The GPT or a transformer, what LLM, whatever we are doing, it will just do that. For example, a university launched a new interdisciplinary. Okay, and the linear equation goes through these options: program, course, center, festival, and it will just put the probabilities for it. For example, as you can see, the program has large number of probabilities because it may have seen this probability more in their vector spaces. And course is there. Course is also obviously it is all like interrelated, right? This training signal is the is what like it will be predicted as the next token. So this is something I can just relate it. So I just want to put it. So as you can see, and it automatically selects the program for next. So that's why it may be a course. That's why the LLMs are prone to hallucination. So LLM is not 100% every time. It may make mistakes. It may make mistakes, So that's why I'm just telling, like, it is completely with the probability. Even if you guys just keep on pondering the GPT or anything with certain question which you are not sure, even it's not sure, it is just throw random tantrums. So that's due to the limitations. This is a limitation. It is a black box. What we tell the black box is, we will not know what's really happening inside. For example, for in a car engine, we know what's happening behind, inside it, because it will have a piston and it is burning the petrol or not. So all these contents we'll be having. But in transformer, we are not sure what is happening. That's the truth. Even the people who founded the Claude Anthropic, they will not know what is happening inside the transformer, what it is learning, what it is leaving out. It's not known. The transformer is a black box model. That's why people will not put transformer into the production of any disciplinary. For example, even in our company, though it's a AI company, for certain some cases, for a privacy problem, for the data privacy, we will not use LLM for the use cases. That's not possible. We will probably develop our own machine learning model or a feed for a neural network, and we will just deploy in our own servers, so that the data of us won't be get exposed to the transformers or the party which is developing the foundational models. So that's what will be happening. Okay. Yeah, like I was telling, right? Why GPU, not CPU? Okay. All the transformers, AI field is completely depend on the GPU. That's why the share market of the Nvidia has been like roof rocketed. This is the reason AI market has been like very dynamic. The market dynamics have been very different. So the CPU capabilities will be good for our general use cases. For example, if you are doing a multitasking, and for example, people who are owning laptops and having a high-end mobiles, you may have seen, like, if you have like multiple folders or multiple applications running parallelly, all these capabilities due to the CPU. Okay, that's a different case. But GPU, what it does better is, it does a parallelism better way than a CPU, because the tensors, transformers are completely dependent on the matrices and tensors. We may have studied in our college days, right? The matrix and the M2, M1 paper matrix. So that's the matrix probabilities will be running behind the transformers. So these computation can't be handled only through the CPU, because it has own limitation codes, everything. But GPU, it's like different ball game. It will have like the enhanced hardware, enhanced core structures, so the parallelisms will be like enormously faster. So that's why even for like frame per seconds kind of games, like hard end games, it requires GPU. So same goes for the transformer. For the TPU is a tensor processing unit which is founded by the Google. So that is also like very efficient for the AI. So all these data centers, right? So GPTs, Cloud, everything will be run through the GPU. GPU will be burning the dollars actually. Even if you ask like, hi, the GPU will be like running down in the San Francisco. Okay, and it will be like using an enormous number of water for it to run, because a GPU, once the GPU is running, it takes a lot of heat, and heat is not good for the hardware component. So that's why the cooling water will be like passed down, and the data centers will be like coming out. So it is also like involves environmental issues. But thing is, GPU is very essential for anything, for a foundational model. If we want to do a small model training, everything, GPU is an essential one. Okay, that's one thing. I'll just make a note of it. Okay, and training loop. I will just explain it further with this diagram. Okay. What's the time? Okay. Let's say like billions of parameters. Okay, what is a parameter? You may ask, like, what is a parameter? Just remember, in your brain cells you'll have like neurons. These neurons will do multiple things, like it will pass the information from one neurons to another. For example, to feel your pain, it have to transfer to millions of neurons in your brain, and it will come to your sensory nerve, and sensory nerve it goes to the body. That's the case of the neural network also. Neural network is same way. The algorithm of neural network also same in the way. So it works like a human brain. Like this is a one parameter neuron. What it does is, like, we have the input is nothing but our data and the output probabilities. It will just know our data. Okay, so to get this input data and output data, what kind of fine tuning I have to do? I won't tell fine tuning, tuning. Fine tuning is a different term in the AI technology, so I will just use it for later. Okay, so these parameters is nothing but it just transfers the information between the neurons, so that what we normally do for a FM radio tuning. Okay, if for example a FM radio is running in 98.9 FM, you have to tune it in that way so it reaches 98.9, then only a frequency of radio will come correctly. Same way for the parameters. If you want a transformer to learn in the accurate way, it have to adjust the bias and the weight so that it learns the pattern behind the data. So it won't memorize anything. The memorization will happen only if there's a repetitive information coming through the transformer. If it is like very rare case of data, it won't remember anything. It will just remember what is the pattern behind the data. Okay, just remember this. This is actually a bigger topic, but due to interest of time, I just want to touch base on this. Just remember as but tuning of FM radio. So this weight and bias will be auto adjusted based on the outcome from the parameters alone. Okay, and let's say if the model is very bigger, obviously the parameters also will be very bigger. For example, the palm model, PALM model, which was trained around with like 550 billion parameter. So what's the reason for it? Because the larger the parameter, it will have like larger ideas and larger information. So we may get larger context and larger information from the chatbot assistant or anything. Okay, that's the reason. Yeah, as you may have seen, right, starting from 2022 to 2026, it's just been like 4 years, but the amount of model capabilities have been improved is very rapid. This is a reason. The reason for this, like, obviously, the more the data, the better the data. Even for every cases, for machine learning problem, for deep learning is nothing but the neural network problem. Neural net algorithm is there now. Neural network, everything, the more the data, the accuracy is, we're gonna obviously gonna impress, because we have like larger subset, and this larger subset will give a way to learn the data. Okay, it will give the way to learn the patterns behind the data. So that's what it is. um, uh, Guys, am I audible? I'm just going with the flow. I just want to make sure like everything's audible.
Yes, sir, you are perfectly audible.
Okay, great. Yeah, and more compute, obviously, because the more the compute, the GPU, GPU companies obviously will make a better GPU. As you can see, I kind of forgot the name. Nvidia have developed a multi-core GPU the size of this. Okay, this is a multi-core GPU now they have made, so that will run a ISRO kind of a big technological space with this kind of GPU itself. So that's the amount of efforts they are putting in the R&D, so that the more the computational is, the better for the AI and the future goes. Okay, and the better architecture, obviously. So how the architecture is getting differed is actually, I want to tell is like, people are doing lot of works for the applied algorithm itself. For example, for GPT is a decoder model. It's not an encoder model; it's a decoder model. Just make note of it. Just study through your inputs. But just I want to touch base on everything, so that it will reach people for almost like everything, every people, every segment of people. So that's why I'm just making note of it. And better architecture. What I mean is like, people are doing lot of algorithm changes, algorithm fine tunings, not only fixated on like, okay, transformer, we got the transformer, we'll be working on that, and we'll be like finding the fruitfulness. No, that's not the case. They are just doing lot of algorithm fine tunings and a lot of changes. So it's obvious, right? And better post training. What's mean by post training is, I'll just tell what it is. See, the training model is separate, and once the training has been done, how this model able to act as an assistant for you? Have you realized that how the GPT is being like very polite to you? Even if you scold it multiple times, it won't scold you back. That's not the case at all, because it has been fine tuned in that way that everyone will know Chitty Robo, right? Everyone should have seen Robo or Indian movie. So the good Rajinikanth, first it will be like, we will be feeding multiple data will be like feeding to the chitty. We will be like feeding it, but then the scientists would have been uh, given a reinforcement learning for him, like don't do this, it's a harmful thing to do in the human. So he will learn, and he will not replicate that problem, that mistake he will not replicate it. Same applies for the transformer. We call it as a reinforcement learning. So the transformers, once it got learned, if it leaves the bad remarks or bad replies, we just give the punishment. What punishment it is? No, it will be like very funny. Everything is numbers in the computer space and IT space, right? We will be giving the value zero. Zero means it will get affected. Zeros and ones, the binaries only it will work. Zeros means it will be like, okay, I have made a mistake, so I won't make this mistake. Though then it will give a better response, and if it gives a better response, we will be giving him treat. Treat is one. Treat means we'll be giving a small reward. Okay, I will give him one. It is performing better, so I will give him one. Same case for the transformers also. We will be giving this the penalty plus reward system, so that it just learns and adjusts, and it just goes through the human feedbacks and all those things, and it just comes as a fruitful model. So these regulations will be happening, then only model will be put in the production space. Not until that, because it is prone to a black box model, it will make mistakes. So for this, a company will spend large and large of millions of dollars for to happen for the post training. The human people will be having lot of prompts with them, and they will be just adjusting the model so that it learns. Okay, this is one thing. Okay, why models has been improved. Okay, so I was telling, right, how the you it has been converted as a helpful assistant rather than being only a informative space, because even Wikipedia is an informative space which has like lot of information, but it won't act as an assistant because it do not have the capabilities of retaining the context and replaying back, because it needs our own chatbot. But it can be done very easily once we hit the Wikipedia's API, and we get the data and put in the vector space, and we get the context, and it just replies. That's a very simple thing. Chatbot in these days is like very simple. We can do in 30 minutes or 1 hour time. That's not a big issue at all. But thing is, how we gonna be training it? How gonna we be fine tuning it? How gonna we gonna make the AI responsible? So that's what how we gonna make it in a controlled environment. So that's what it is all about, like converting a base model is nothing but it's fed with like large information. All the information it will be having, but it won't act as an assistant, it won't act as a helper, because that's the post betterment of training. So that's what all the companies will be like doing once a training. All the versions have been already been trained. It should have been trained by GPT, but it takes almost like 6 to 7 months for releasing the model after the post betterment of the training. It have to get a better feedbacks, better reply. At last, it should help the customer. It's not like overpower the customer. So that should be the idea behind all these AI companies of Claude and GPTs and everything. So that's one thing. Okay, how we adapt and use the models. So this is very industry based. Okay, but I want to touch upon this because I think almost like people who are interested in the AI field should know about it. Probably they may have like learned about it, like all the prompting techniques or hack techniques. But I like to just convey this in the very simple manner, so that you can just remember it whenever you want. So that's how I just want to tell it. So how we want to adapt and use the models. Okay. First is like prompting. Whatever we are doing, we are just like doing a prompting. Prompting is nothing but giving the structural instructions to the model, and model gives a feedback. So that's the thing, wholly. Okay, but in certain prompting technique itself, we in the industry we use guardrails. Guardrails is nothing but guardrails is nothing but let's say we are putting fence over the model so that it won't go out of boundaries. But you may ask the question like, after the post training itself, human have been like giving a reward and a penalty, right? So how it will go out of context? But that's not the case in the industry. In industry, for example, I'm working for a pharma company, for a client, a big customer. it's a pharma company. They are one of the Fortune 500 company. Okay, so what they want is the model should not answer any basic or general question. It should work only for the pharma questions and pharma related domain specific questions. So this kind of prompting techniques, what we can do is we can use guardrails. Guardrails, I didn't mention here. Probably I can tell the spelling like GUARD RAILS. Okay, guard rails. Guard is God. Rails is rails. Okay, guard rails. Okay, it's just nothing but a fence for a model. You just work, you should work only through the domain specific answers. You should not breach that. So that's what we do in the industry for to hold the model in the controlled environment. So that's what is called as guardrails. And prompting techniques, obviously the prompting is nothing but giving a set of instruction and giving the intent behind the context for the model to give the feedback for you. It is a prompting. And even in industry, we will be having a separate prompt file for the system instruction. For example, I'm developing one content generation model. That content generation model, what it does is like if there is on PDF, out of the PDF, it have to develop one summary for me. So what I'll probably do is I'll be creating one prompt file with the system prompt. See, you are a best content generator for if we give a certain PDF, you have to give me this set of answers. So this is the system prompt we'll be giving. People are giving in a generalized GPT itself, like they'll be editing their photo, right? They'll be just giving a set of prompts and the intent behind it. So that's what the prompt is. We are just giving the instruction for the model to give a well-designed task rather than giving a generalized answer. Even it's going to give you a generalized answer, but it will be giving a specific way that you require. So that's what is prompting is. Nothing fancy, nothing here. And I have seen like a lot of videos. In future the prompt engineering going to be very good work. That's not the case. Prompt engineering is not a role at all in the industry. That's a reality. Okay, that's why I want to tell you one thing. Okay. And RAG, this is the most pivotal thing happening for industry for last 2 years, and currently also we are using RAG, and in the future also it's gonna be here for a long time. What's RAG? Retrieval augmented generation. Nothing fancy. Here also is nothing fancy. See, we have already a foundational model. For example, a GPT 5.5 is already there. GPT 5.5 is trained with like large number of details and information. For example, if you ask any general data for a medicine questions, it will be answering you. If you ask on EC questions, it's gonna answer you. If you're gonna get want to do a OOPS concept for a computer science, it's gonna answer you. Anyway, it's gonna answer you, but because it is trained with like multiple source of data. But for example, I'm developing one chatbot for one pharma company, but that pharma company should have a domain specific chatbot alone. How can I do it? So here we have like two ways. One is fine tuning, one is RAG. Fine tuning is a training the model with the data. That's one thing. And RAG is like data will be like uh, keep on changing up, and it will be keep on adding up to the database. Okay, that's the case because that's what will happen. Even if you leave WhatsApp for like 10 days, you will be getting like 100 plus photos additionally newly will be added. That's the case of all the industries because the data gonna be it's going to keep on adding up to the storage. Okay, so RAG what it normally does is let's just say you have like all the policy documents. For example, I want to create one chatbot specific for the AMS college. Okay, what I will probably do is I'll get all the details in sense, all the documents, all the data for whatever specific for the AMS college for policy details and what's the fee structure and the student policy details and faculty for faculty details and all this data and what the student have been scoring, all this data, every data. I'll be like probably what I'll take the data, I'll clean and pass the data, and pass the data. I'll be storing the data as the embeddings from the vector stores. What we'll be doing? No, we'll be like storing as a chunks. Let's keep it as a chunks. CHUNKS chunks. These chunks will be stored in the vector space. Okay, once it stores, and how I will be like doing, no, the transformers or the LLMs can be fine tuned with the parameter called a temperature. Temperature, I think people who are in AI space may know what is temperature is, but people who are new and from the different domain, the temperature is nothing but the the value of a percentage of creativity a transformer have to replicate. For example, if I put temperature as 0.0, it will have zero creativity. It will be like very deterministic. Okay, it will be very deterministic. But if I put a point 0.9, okay, 0.9, it means if the creativity is about 90%. What will do? No, it will just take 10% of data and 90% of creativity, and just it will be collide and it will be giving it. It depends on the people's need and the intent what they need. For example, if they want to put one image and this they want to adjust the temperature, and means it will have like lot of creativity in output. It may or may not may look like that person, but you don't want that creativity. You have to adjust to that temperature to keep it reality. We have to keep the temperature point 0, 0.2, 0.0. So what we in industry we does is this rag application we make in that way, so that it did not want to give a extraterritorial answer. Only it should work with the documents I have given it. Okay, that's what is RAG is. It won't have to get trained, because the fine tuning. If we want to train that data, whatever the RAG data I got for the AMS, if I want to train this, I will, it will cost a crores for me. Okay, if I want to train that model, it will take crores for me. But if I do that with the RAG application, like I will use one foundation model API, for example, a GPT, and I will be using one of the, for example, I'll be using a 5.5 GPT and using the AMS data, and I will collectively I'll put as a chunk, and from the chunk, the best chunk I'll be taking from it with the similarity search. And if the better similarity searches, like for example, we use normally cosine similarities, and it will take the best chunk, and that best chunk will be articulated. That's what the LLM will be doing. It is just take the best chunk based on the context. For example, which are the students have cleared this particular subject in EC department. I'm just asking one query. What it does is it just goes through that the student, the department, EC. These words will be converted as a embeddings, and it will go through the vector stores, and it will see the probabilities. Okay, where and all this data has been there. Okay, this data is here. Okay, EC students data is here. Okay, the EC student data is here. I will fetch that chunks, and I'll be coming back, and I'll be replicating that. So that's what the LLM will be doing in the RAG application. It won't be trained with the data. The data will be put in the private space alone. It won't be exposed at all. So all the important pivoting industries, if the data is very dynamic, it's not static. Static and dynamic, you know the difference, right? Dynamic is it will keep on changing. If that's the case, we can't just do multiple training. Okay, the data will be like very dynamic. It will just keep on adding up. The better thing we have to do is RAG application. RAG application, with this itself we can be able to get the data. So that's one thing. And how we will be like foolproofing it, and we will be testing it out is ground answer. We'll be having one human here in the chatbot, and you will be like asking the questions, and if it is like relevant to the ground truth with the policy alone, you will be like, okay, the RAG application is working fine. If it is like telling out of context answer means, okay, RAG has its mistake, we have to do small changes, parameter changes, something we have to do, then RAG application will be working fine. So this is what it is, and the RAG application still exists in the industry. It's one of the big money making project, but still it's in the industry. In future also it will be there until there is a replacement for better quantization. This should be the quantization. I'll be explaining in next slide. So understand the RAG, which is like very important for the industry, even for the freshers and for people who are coming. We see if they know RAG or not. So that's one thing. Okay, and prompting RAG I have told. Okay, fine tuning nothing. It's like training the model. Okay, the only case we recommend fine tuning is we in Indian companies most of the Indian companies in the service work company, people don't do fine tuning because we are not a, a perfect AI engineers or a perfect AI companies. We are doing applied AI. Applied AI is nothing but we already have a trained model and we'll be using that in our use case, like for a RAG application for prompting. We'll be using that. We Indians, we do not have our own AI because there's a lot of reason for it. It's like lack of infrastructure, and we do not have the brains behind it because all the brains is in MIT probably. So that's the reason we do not have our own AI. We are whatever we are doing here is applied AI. But there are instances we have did fine tuning, but that's for the like very small use cases. Nothing. Fine tuning is if there is one task or if there is one data, the data would not change for next 10 years. Then what we're going to do? We can do a fine tuning. We can make one model for a chatbot or anything. We can just make a model trained with that data, and that model will know only that data. Okay, if you ask a basic questions, A for apple means he won't tell A for apple because it's not trained with that data. It is trained with only specific data. For example, I fine tune a model with the AMS college. It only knows AMS college details alone. Even if, for example, it is trained with one principal name, with the AMS college, he is a so principal. It got trained. Even next week, or a new principal has been omitted, and that principal got relieved or something. Okay, new principal got onboarded. Still, that model will tell the old principal name because it got fine tuned with that old data. With the only new data, it can be replaced, or else it will be stale. So this staleness means it won't have any changes. The staleness is like very backdropped or very old versioned. So that's what the stale is. So it is we call this as a model stale. So model will be stale. So probably most of the ways we won't recommend our customers or the clients for the fine tuning. But there is some cases which like data won't be changing for next 10 to 5 years. Then that's the case will be. But this is also like very expensive. Fine tuning is very expensive. It's not like simple things. If for RAG application it is taking like $5 for per day. Okay, for doing a fine tuning, it may take around like 50,000 to $60,000, which is like humongous numbers for a training alone. Because later it is also having the hosting and deployment charges. It's the lot is there. Okay. Okay, this is on fine tuning and build and train. Same, almost fine tuning and everything is same. And I want to touch base on this also. Quantization. The quantization techniques are LoRa and CLoRa. Okay, these are the two quantization which normally we do because we don't want to retrain everything. Okay, we want to retain the model with like basic parameters it have to know. For example, it should not be a stupid model. It have to know basic things. For example, actually there is a domain specific models for each and every department. If you know, there is one separate model for max alone. If you ask that model any type of mathematical question, it will answer better than a generalized model like ChatGPT or Claude. Okay, because it is trained with only domain specific math problem, math data alone. So that cases, if I want to use that math model and I have some math data with me, what I can do is I can probably use that model. I can quantize and I can do a pruning. Pruning is nothing but I could reduce the parameters and I could attach some of the data as a parameters to the existing model. It's like you have like bigger data. If you have like smaller data, you just attaching it here. This process is called as quantization, and this quantization will be like once it is integrated, we'll make as a package and we'll be just feeding as a deployment. I'm just telling it very plainly, but it involves a lot of technical details. But I just want to tell in the simple manner. Okay, that's how it is. So already a foundation model is that on small data you have. If you want to do, if you want to have your own model, then this is a technique. So this techniques differs like 4-bit base model and LoRa. So this is already there. So these are the two techniques. Okay. Okay, and agent. Okay, I'll just go through the agents or very simply, in a simple way. Agents is nothing fancy. Just you have like 5 to 6 models here. Okay, and one model will be a manager model, the model which controls the loop of the agentic. framework. Okay, that model will be, we call it as a manager model. Okay, that manager model will have access for that other supplementary model. For example, I will tell in the student perspective itself. Like I have one model for the max, one model for the electronics, and one model for DSP. One model is for I'm an EC student. I just remember like one or two subjects. So you have like ESP, some question, some subject is there. So all these models will be like connected with one manager model. That manager model will connect it with the user intent. So this manager model is here, and I'm asking a question. Okay, I will ask one signal processing question, and this manager model, it have to find a specific agent based on my intent. My intent is to find a signal processing question, and this manager model, what will go, it will directly go to DSP model, and it will ask the answer, and this DSP model will answer the manager model. This manager model filters and gives me the better answer, so that it accomplishes my intent behind it to find the signal processing. So that's what is same thing. Plan, act, observe, reflect. So see, these problem conditions will be like resolved using the agents, and we have like a lot of agentic frameworks. I ask like students or people who are coming as a freshers to go through land graph and um, a land graph, because that's a better agentic framework as of now, and to see all the how it works as the agent, because see, everything we can develop within a 1 or 2 days, but thing is having the foundation knowledge, what's going behind it is a preferable for industry and for us. Okay, this is one thing. And this is all like very general thing, as an academic support system, how we want to have. This is how the future may looks like. Okay, so um, the, the timetables, all these can be preferably in future. Everything will be done with the AI. So that's one thing. And yeah, so due to interest of time, I have to complete as soon as possible. So okay. So yeah, as in this industry, in this space, so I will be like getting a lot of questions like how the future goes full flights. Okay, so I'll just tell our team structure how it looks in the future. Also, this should be the case. Okay, so cyber security for any software, it not gonna be replaced very soon, because cybersecurity can't be judged or put into a black box LLM model. That's not the case. Any companies would not do that. So that's one pivotal role we will be having here. And DevOps also, that's the case, because we will be having like sensitive data and tokens and environment files for our software or application we make. So that's not gonna be replaced. And data engineers, so they are very pivotal for our projects, because they are the one who makes a pipeline, data pipeline for us, so that the model works streamlinedly. And as a backend AI engineers, we'll be like put into only the task of us. Though we don't take a burden of handling the data by ourselves, though we will be handling, but later stages only, not in this first sanitize and stitching stages itself. We will not do that. It's like all the raw works will be done by data engineers, and our work is like building the application, all those stuffs. So then it goes for like, again, DevOps team comes into picture. They will be the one packaging the model and just distribute the model to the certain countries, and users can be accessed. So this is how it is. And in future also, that work dynamics may change. Definitely there's going to be a change, but people who going to use responsibly the AI and for their daily works, never going to be changed. Actually they're going to be step up, and they're going to put in the better space. So it's not actually human versus AI, it's human and AI. So I want to conclude in that way, so that people understand it's not, that's not the case. actually. I have seen in the industry. I am in the industry, so I know what's happening. Maybe the stale works and the repeated works. Maybe it will be like replaced by AI because we are doing that tasks. Okay, I know like some of the repetitive works can be replaced, but essence of the works can't be replaced. Specifically, faculties and the teachers, the classroom programs never going to be replaced because the cognitive ability of the students only be developed only in the classrooms, not in the space of YouTube. Because even if you can see, YouTube will have like lots of content, but there is no better program than the classroom programs. But after all this realization only, I'm just coming into the picture that some of the essence where people needs empathy, judgment, and all the humans in the feedbacks never gonna be replaced. But it's all about like we gonna be improvised with the productivity and all those changes. So yeah, this way I want to conclude the session. So you guys have any questions? Maybe we can shoot up quickly.
So any questions from audience? Okay, please, you can type in chat box. We'll respond to you. Balaji sir, so far no.
Okay, great. So thank you, sir.
Thank you. So I'm coming to the end of the part. I'm just going to give a vote of thanks here. So on behalf of our respected secretary sir in absentia and our respected principal sir, Dr. K.G. Parthiban in absentia, respected Dr. A. Salma Banu, Vice Principal ma'am, respected our HOD, Dr. R. Lavanya in absentia. So, on behalf of our entire AIDS team, our coordinators, and also AML team members, and we are very thankful to Mr. Balaji, and who is very experienced in this area because a lot of technical knowledge he has today shared, and most probably it will be very good for us to go with and get some ideas on doing projects as well as the research oriented projects any kind of papers, journal papers for us, very useful for us. Thank you, sir. Thank you very much.
Thank you. It was nice session. Thank you.
So we are proud of you, sir, because since you are alumni from 2015 to 19 from EC department, I'll convey this thing to our known alumni of EC.
Okay.
So for your session, wonderful help, timely help.
Thank you, sir. Thank you.
So we'll wait for 5 minutes so that they will fill the. Thank you. Balaji sir, if you want to wind up, no issue. You can wind
Okay.
up.
Thank you.
Thank you. Thank you.